Hi guys, so in today's video we're going to go back to the Pythagorean theorem and we're going to start using it to determine whether a triangle is a right triangle or not a right triangle. Okay, so to do this we have to understand that the converse of the Pythagorean theorem says that if a squared plus b squared equals c squared, if that is true, then the triangle is a right triangle. Entonces, si usted tiene los tres lados, tiene el lado A, B y C, y si usted usa Pythagorean Theorem, A cuadrado más B cuadrado igual a C cuadrado, si los dos lados te da el mismo resultado, entonces usted puede decir con 100% de seguridad que ese triángulo es un right triangle. Porque a veces no te van a dar la figura, a veces te van a dar los lados nomás y usted tiene que ver si es un right triangle o no. Okay, so let's look at how you would tell or what kind of examples you would see. Vamos a usar el Pythagorean Theorem para mostrar si este triángulo realmente tiene 90 grados. Ok, entonces empiezo con a squared plus b squared equals c squared. Now, acuérdese, en el último video de Pythagorean Theorem, yo te dije que el lado C es el hypotenuse, el lado más grande. Okay, entonces, si yo veo estos números, la primera cosa, igual cuando estaba usando Pythagorean Theorem, I always told you, find the hypotenuse first. Aquí voy a hacer la misma cosa. Voy a encontrar el lado más grande, so that would be 41. And I know that that's going to be my side C. De nuevo, los otros dos pueden ser su A y B. I always do the smallest side as A and the other side as B. All right? So here I'm going to do 9 squared plus 40 squared equals 41 squared. Okay, la única cosa, tomé los lados, lo puse en la ecuación. Now, simplificamos. 9 squared is 81. 40 squared, 1,600. 41 squared, 1,681. Suma estos dos, I get 1,681 equals 1,681. Los dos lados son igual, entonces yo sé que este triángulo is a right triangle. Y esa es la única cosa que estamos viendo, es si el triángulo tiene unos 90 grados, okay? And this is a way to show that. Let's try the next one. Again, voy a empezar con la ecuación a squared plus b squared equals c squared. I'm going to start with my side C. 18, 12, 24. 24 is the biggest one. That's my side C. 12 squared plus 18 squared equals 24 squared. Acuérdense, si esto trabaja, cuando usted hace a squared plus b squared, te debería de estar el mismo valor que c squared. All right, so 12 squared is 144. 18 squared is 324. And 24 squared is 576. Now, cuando sumo estos dos, I get 468. So you can see this is not equal. Okay? Lados A y B no me dan el mismo valor que el lado C. So here, this is not a right triangle. So again here, la única cosa que te dan son los lados. La primera cosa, busca el lado más grande. That's your side C. Coming over here, look for the biggest side. That's your side C. So again, a squared plus b squared equals c squared. So you're going to have 20 squared plus 21 squared equals 28 squared. Ve si los dos lados son igual. And over here, you're going to have 0.75 squared plus 1 squared equals 1.25 squared. Y ve si los dos lados son igual. Now, la segunda parte is the distance formula. Now, the distance formula, de nuevo, se usa cuando usted a lo mejor no tiene un triángulo donde puede fácilmente usar Pythagorean Theorem. Estamos buscando un lado, maybe on a graph is where you would see your distance formula. Here's the distance formula. Y si usted ve, looks like one big square root. Now looking at the inside, usted va a ver x2 menos x1 cuadrado más y2 menos y1 cuadrado. Where have you seen this before? This looks kind of familiar to me. Were you thinking when you found slope? Yes, because it's kind of almost, you should see it, it almost reminds you of a slope, y2 minus y1 over x2 minus x1. So if now you're thinking, oh yes, I remember this, esa idea, como usamos el slope formula ahí, usted lo van a ver aquí. Okay, de nuevo, si usted mira aquí ejemplo número 2, empiezan con 2 puntos, okay, 2 points on a grid. Que era la primera cosa, cuando usamos slope, dije que tenía que identificar x, y, x, y. Este es el primer punto, este es el segundo punto. Now, instead of putting it in the slope equation, we're going to use the distance equation. Usted puede tomar estos puntos y si tenía papel gráfico, usted lo puede poner en la gráfica, dibujar la línea, dibujar las otras líneas para formar su triángulo y hacerlo like that, but that could take forever. Esta manera te lo va a dar esa misma distancia, but a lot quicker. Alright, so I'm going to start. La distancia es igual a big square root symbol. I have x2 minus x1 squared plus, so that could be like my a squared plus, what, b squared, right? So this is y2 minus y1 squared. I'm going to have x2. So I'm going to go to the second point, and here's x2 is a negative 4. So I'm going to have negative 4 minus x1. x1 was right here. That's 1. And that's going to be squared. Plus, now let's move to our y values. y2, si usted me ve aquí, this is y2, is going to be a negative 2 minus y1, which is 5, and that's all squared. So distance formula equals the square root of negative 4 minus 1 is going to be negative 5 squared, plus negative 2 minus 5, negative 7 squared. Now quiero resolver el cuadrado. So here, negativo 5 por negativo 5 is going to be my positive 25. Negative 7 times negative 7, positive 49. You add that together and you get 74. Now, 64, is that perfect? No. Entonces, así es como vamos a dejar nuestra respuesta. This is not perfect, so leave it alone. Okay, lo voy a dejar como una distancia de raíz cuadrada de 74. Okay, de nuevo aquí abajo tenéis 3 ejemplos so that you can practice. Again, la única cosa que es importante es venir aquí primero y decir, okay, this is x1, y1, x2, y2. Después, como hice en el ejemplo, empezar aquí con la ecuación, reemplazar sus valores y después empezar a simplificar. Si es perfecto, if it's perfect, go ahead and simplify. Pero si no es perfecto, déjalo así nomás. Let's look at one of these problems here. So you design a football play in which player runs down the field, making 90-degree turns, and runs to the corner of the end of the zone. Your friend runs the play as shown. Did your friend make a 90-degree turn? Each unit of the grid represents 10 feet. Okay? Entonces, lo que yo quiero saber es las distancias aquí de cada vuelta o entre la vuelta que él dio. So I start here. Voy a empezar aquí. And now if you see, yo quiero saber esta distancia, D1. Entonces, empezando con estos puntos, that's what I'm going to look at first. Entonces, voy a tener 60 y 50 y 30 y 20. X1, Y1, X2, Y2. De número 1. De nuevo, this long equation. I'm going to have X2 minus x1 squared. And then y2 minus y1 squared. Okay, you're going to have negative 30 squared, and you're going to have negative 30 squared. So here, negativo 30 por negativo 30, you're going to have 900 plus 900. And now you're going to have the square root of 1,800 feet. Okay, I'm going to leave it there for now because I now have to find the other sides. So now I'm going to do the same thing for D2. Entonces, empezando de aquí, where I'm at right now, I'm going to come all the way here. So now I'm using this point here. Y acuérdate, este es 0. So when you look at here, este es negativo 30. Okay, so again, now I'm going to use D2. I'm going to change color so you don't get mixed up so much. So I'm going to have 30, 20, y ahora 80, and negative 30. So x1, y1, x2, y2. D2 equals, I'm going to do 80 minus 30 squared plus negative 30 minus 20 squared. Again, 80 menos 30, you're going to have 50 squared. Negative 30 minus 20, you're going to have a negative 50 squared. You're going to end up with 500 plus 2,500. So that's going to give me the square root of 5,000 feet. Simplemente usando la fórmula, okay, your distance formula, y usando los puntos. That's all I'm doing here. Okay, el último lado que tengo que encontrar es D3. Okay, so from here to here, 80 and negative 30. And my other point donde voy a terminar is 60 and 50. X1, Y1, X1, Y1. So here I'm going to do D3 is equal to los valores de X primero. Oops, these are 2's. 60 minus 80 squared. Now los valores de Y. 50 menos, careful with this one, este es menos 30 squared. Menos con menos es más. Careful with that. Here you're going to end up with negative 20 squared plus, here you're going to have 80 squared. 20 times 20, you're going to get 400. And 80 times 80, you're going to get 6,400. Plus 400, you're going to get square root of 6,800 feet. Entonces, real quick, la primera cosa es que encontré las distancias of all of these points. This one here being D1, okay? Y cuando encontré D1, encontré que este lado era square root of 1,800 feet. Después, usando los puntos, encontré D2, 6,800. I found the 3 sides. That was a lot. Pero como usted puede ver, si usted me siguió, that's really good practice using the distance formula. Now quiero saber si este turn right here, ¿viste how it says that's the turn? Si él dio vuelta 90 grados, vamos a usar la primera parte que era, ok, si a squared plus b squared tiene el mismo valor que c squared, entonces sabemos que tenemos 90 grados. That's the whole point of this example. Mezclaron distance formula con el converse of the Pythagorean Theorem. A squared plus b squared equals c squared. Quiero saber si este turn que él tomó era 90 grados. Entonces voy a tomar los lados. Acuérdate, el lado más grande va a ser C, which is this one right here. So I'm going to do square root of 1,800 squared plus the square root of 5,000 squared is going to equal the square root of 6,800 squared. Now, esto should look familiar. Acuérdense, square root of a square se cancelan. So I'm left with 1,800 plus 5,000 equals 6,800. When you add these two, te da el mismo resultado. Entonces, este turn was a 90-degree turn. Regresando a la pregunta, did your friend make that 90-degree turn? Yes. Okay. So that there is an example of your distance formula y después usando el converse of the Pythagorean theorem. Si a cuadrado más b cuadrado es igual a c cuadrado, tenemos ese triángulo de 90 grados. So take your time with this one, go through the big ideas problems, and remember, you can always reach me on Google Classroom or Remind if you have more questions. Bye guys.